Hive is a popular tool used in data warehousing solutions and is often a common topic in data science interviews. This video is designed to prepare you for such interviews by covering the top 25 most frequently asked Hive interview questions and their answers. These questions range from basic to advanced levels, ensuring that you're well prepared for any Hive-related query you might face during your interview. By understanding these questions and their answers, you'll be better equipped to demonstrate your Hive expertise and land your dream job. 1. What is Apache Hive? Apache Hive is a data warehouse software project that was developed to facilitate reading, writing, and managing large datasets that reside in distributed storage and queried using SQL syntax. It's a part of the Hadoop ecosystem that provides an interface for performing queries and managing large datasets stored in Hadoop-compatible file systems. Hive provides tools that enable easy data extraction, transformation, and loading, ETL. It also provides the ability to query data using a language very similar to standard ANSI SQL, known as Hive Query Language, HQL. This makes it a very powerful tool for handling big data and performing analytics. 2. What is the Hive Query Language, HQL? Hive Query Language, often referred to as HQL, is a programming language that is similar to SQL. Its primary function is to manage and query large datasets that are stored in the Hadoop Distributed File System, HDFS, or other compatible data storage systems. HQL enables professionals to execute SQL-like queries on data stored in various databases and file systems that integrate with Hadoop. Unlike SQL, HQL provides full support for MapReduce functions, allowing developers to plug in their custom mappers and reducers to perform complex analyses that are not supported by built-in capabilities of Hive. HQL bridges the gap between traditional SQL databases and the Hadoop ecosystem by providing a mechanism to project structure onto the data and query it efficiently. It also allows users to use their existing SQL skillset to easily explore and analyze data in Hadoop. It's worth noting that while HQL is similar to SQL, there are differences due to the big data environment and the distributed nature of Hadoop. 3. What are the main components of Hive architecture? The main components of Hive architecture include the following: User Interface, UI. This allows users to submit queries and other operations to the system. Driver. This component receives the queries submitted through the UI. It then creates session handles for the queries and forwards these to the compiler for execution. Compiler. The compiler transforms SQL queries into an execution plan, which consists of MapReduce tasks that can be understood by Hadoop. Metastore. This stores metadata for each of the tables such as their schema and location. Execution engine. This component executes the execution plan created by the compiler using a combination of Hadoop MapReduce and HDFS, Hadoop Distributed File System. HDFS, Hadoop Distributed File System. This is the storage layer for Hive where it stores and retrieves datasets. Each of these components plays a vital role in executing queries and returning results to the user. 4. What types of tables does Hive support? Hive supports two types of tables: managed tables and external tables. Managed tables, also known as internal tables, are the default table in Hive. When you create a managed table, Hive takes care of the data loading, management, and storage. If you delete a managed table, both the data and the schema are deleted from the Hive warehouse. External tables, on the other hand, are used when Hive is not responsible for the data and its storage. The data resides outside of the Hive warehouse. When you delete an external table, only the schema is deleted from the Hive warehouse, the data remains intact. The choice between managed and external tables depends on the specific use case and how you want to manage and interact with your data. Hive supports both managed tables and external tables. If a managed table is created, Hive is accountable for the data, its loading and storage. Erasing a managed table results in both the metadata and the data being erased from the Hive warehouse. On the other hand, an external table allows the data to remain outside of the Hive warehouse. So, if an external table is erased, only the metadata is erased from the Hive warehouse, the data still remains. Hence, whether to use a managed table or an external table depends on the unique use case and how one wants to manage the data. 5. When would you use Hive over traditional RDBMS? Hive is often chosen over traditional RDBMS for its ability to handle big data. While RDBMS is ideal for managing structured data, they often struggle with the sheer volume of data that Hive can easily process. Hive, as part of the Hadoop ecosystem, is designed specifically for dealing with large datasets across distributed systems, providing scalability that RDBMS cannot. Hive also offers a simple query language, HQL, which is similar to SQL and easy for those familiar with SQL to pick up. This can lower the learning curve for teams transitioning from traditional RDBMS to Hive. Additionally, Hive's architecture allows for data to be stored in a variety of formats, including text files, ORC, and Parquet, among others. This flexibility is not typically found in traditional RDBMS. Finally, Hive's integration with other Hadoop tools like Pig, Spark, and HBase make it a powerful tool in the big data ecosystem. 6. What is partitioning in Hive? Partitioning in Hive is a way to organize tables into smaller parts based on the values of certain columns, such as date, city, and department. This process is similar to dividing a large book into chapters, making data reading and writing more efficient. Partitioning can significantly reduce the time taken to perform queries on large datasets by only scanning the relevant partitions of the data. In essence, partitioning is a mechanism to achieve better performance on Hive queries. Partitioning in Hive allows for faster data retrieval as it reduces the data volume by enabling the query to run on a subset of the data. When one creates a partition, Hive creates a new directory for each unique value of a partition column. As a result, all the data with the same value of the partition column will be stored in the corresponding directory. This allows queries to run faster as they only need to scan relevant data directories, ignoring the rest. 7. Can you explain bucketing in Hive? Bucketing in Hive is a technique similar to partitioning, but it offers a more granular partitioning option. It aids in evenly distributing load or data across multiple nodes. The data in Hive is divided into a fixed number of buckets based on the hash function of a column in a table. This process is done during the creation of a table. The advantage of bucketing is that it allows efficient querying of data by reducing the volume of data to be scanned. Particularly when you're dealing with large datasets, this can significantly improve query performance. However, it's worth noting that deciding the number of buckets requires careful planning. Too few can lead to uneven data distribution, while too many can result in small, unmanageable files. Bucketing in Hive is a data organizing technique, which helps in evenly distributing data across defined buckets. It functions by dividing data into a fixed number of buckets, based on the hash function of a specific column in a table. This operation is executed during the creation of a table. The main advantage of using bucketing is that it allows efficient querying of data by reducing the amount of data that needs to be scanned. This can be particularly beneficial when dealing with extensive datasets. However, deciding the optimal number of buckets requires careful planning. Too few buckets can lead to uneven data distribution, while too many can result in small, unmanageable files. 8. What are user-defined functions, UDF, in Hive? User-defined functions, UDFs, in Hive are powerful tools that allow you to extend the functionality of Hive Query Language, HQL. They enable you to write custom code and implement complex business logic that cannot be expressed using built-in Hive functions. UDFs are used to manipulate data types, perform calculations, and handle strings. They are written in Java and loaded into Hive at runtime. UDFs can be simple, taking in parameters and returning a single value, or they can be complex, returning multiple values in the form of a map, array, or struct. In Hive, user-defined functions, UDFs, are a way to extend the functionality of Hive Query Language. They make it possible for users to create their own custom functions that can be used in a query. These custom functions can be created to perform complex calculations, handle specific data types, or manipulate strings. UDFs are created using Java and loaded into Hive as needed. These functions can be as simple as accepting parameters and returning a single value, or as complex as returning multiple values in a variety of formats, such as maps, arrays, or structs. 9. How does Hive handle schema evolution? Hive is very flexible when it comes to schema evolution. It allows users to add new columns or modify existing ones in the table schema while keeping the existing data intact. This is possible because Hive schema is applied at read time rather than write time. For example, if a table was initially created with 3 columns and later a 4th column was added, the existing data would still be read correctly. The new records would include the additional column, but for old records, the new column would return null values. Another important aspect is that Hive supports changing the data type of a column, but with some limitations. For instance, you can change a column from int to bigint or from float to double, but not the other way around as it might lead to loss of data. However, it's crucial to note that schema evolution in Hive doesn't support changes in complex data types like arrays, maps, and structs. It also doesn't allow changes in partition columns. It's advisable to design the schema carefully from the beginning to avoid significant modifications later. 10. What is the purpose of the metastore in Hive? The metastore in Hive serves as the central repository for metadata information. It stores metadata for Hive tables such as their schema and location, and partition metadata such as the location and values. This metadata is used during the query compilation phase, where the metastore is queried to get schema information about the tables. The metastore can run in the same process as the Hive service, also known as embedded mode, or as a standalone service, also known as standalone mode. In standalone mode, it allows multiple Hive sessions to share the metadata, thus providing a more scalable solution. The metastore in Hive acts as a bridge between Hive and the underlying Hadoop data storage system. It holds vital metadata about the tables in the Hive database, such as their structure, columns and types, location of the data, and other attributes like the storage format. When a user submits a query, Hive communicates with the metastore to understand the structure of the tables involved in the query, their data types, and where the data is located. This information is crucial for Hive to execute the query efficiently. The metastore also helps in managing and organizing the data in Hive. It aids in partitioning the data to enhance query performance. By storing the metadata separately from the actual data, it ensures consistent and efficient data management. 11. What are the limitations of using Hive? Hive is not designed for online transaction processing, OLTP, and does not offer real-time queries or row-level updates. It is best suited for batch processing and extract, transform, load, ETL, tasks. Hive queries have high latency because they are converted into MapReduce jobs which take time to run. Also, Hive does not support subqueries in a where clause, and the join operation is restricted to equality comparisons. Another limitation is that Hive does not provide a full SQL compatibility, hence some SQL features like transactions are not supported. Hive, being a data warehousing tool, was primarily created for data analysis and reporting, not for real-time transactions or data retrieval. As it is built on top of Hadoop, it inherits Hadoop's limitations such as latency in processing. It also lacks support for row-level insert, update, and delete operations. This makes it less suitable for applications requiring real-time data processing or interactive data analysis. Additionally, while Hive's SQL-like interface is user-friendly, it does not support all SQL features, limiting its usability for complex queries. The lack of indexing can also result in slower query performance compared to traditional databases. 12. How does Hive integrate with other Hadoop ecosystem tools? Hive is a data warehouse software that facilitates reading, writing, and managing large datasets residing in distributed storage using SQL. Its structure and data types allow it to be integrated with many tools in the Hadoop ecosystem. For instance, Hive can be used with HBase, a NoSQL database, to enable real-time queries and updates of large datasets. Hive can also be used with Apache Pig, another high-level platform for creating MapReduce programs used with Hadoop. Pig scripts can read data from Hive and write data to it. This allows for a seamless transfer of data between the two tools. In addition, Hive integrates with Apache Spark, a fast and general-purpose cluster computing system. Spark SQL can read data from Hive and use it to run SQL queries. This allows for the processing of large amounts of data in a distributed environment. Lastly, Hive also integrates with Apache Flink, a stream processing framework. Flink can read data from Hive and use it to perform real-time data analytics. This enhances the ability of Hive to process large amounts of data in real time. In each of these cases, Hive plays a vital role in the efficient handling, processing, and querying of big data. Thus, Hive's ability to integrate with other Hadoop ecosystem tools greatly enhances its functionality and usability. 13. What is the difference between MapReduce mode and local mode in Hive? Hive operates in two different modes, MapReduce and local. The mode selection depends on the size of data that is being processed. MapReduce mode is used when dealing with large datasets. In this mode, the processing is distributed across multiple nodes in a Hadoop cluster. This method makes use of Hadoop's MapReduce framework for distributed data processing. It is the default mode used by Hive and is ideal for processing large amounts of data. On the other hand, local mode is used when dealing with smaller datasets. In local mode, all the data processing is done on a single machine without utilizing the Hadoop MapReduce framework. This mode is faster than MapReduce mode for small datasets as it avoids the overhead of MapReduce job setup and teardown. It's important to choose the appropriate mode based on the data size to optimize processing time. 14. Explain how indexing works in Hive. Hive indexing creates data structures that the system can use to quickly look up data in a table. By default, Hive reads all the data in a table and then filters it based on the query's conditions. However, this can be inefficient if only a small portion of the data in the table is needed. Indexing addresses this problem by providing a way to directly access the required data. While creating an index, Hive stores the value of the indexed column and the corresponding address of the row. When a query is run, Hive uses this index to directly access the data, significantly reducing the amount of data read and improving query performance. Indexes in Hive are flexible and support different types of data structures such as bitmap indexes and B-tree indexes. Indexing in Hive is a powerful tool that aids in quick data lookup, particularly in tables with massive datasets. By storing the value of an indexed column along with its row address, Hive can swiftly access the necessary data when a query is executed. This technique significantly minimizes data read, thereby enhancing query performance. Hive indexes are versatile, supporting a range of data structures like bitmap indexes and B-tree indexes. Remember that while indexes can speed up read operations, they can also slow down write operations as the index needs to be updated whenever data is inserted or updated. Hence, it's crucial to strike a balance between read and write operations while using indexing in Hive. 15. What are the different types of joins supported by Hive? Hive supports several types of joins, including inner join, left outer join, right outer join, and full outer join. An inner join returns records that have matching values in both tables involved in the join. A left outer join returns all the records from the left table and the matched records from the right table. If there is no match, the result is null from the right side. A right outer join returns all the records from the right table and the matched records from the left table. If there is no match, the result is null on the left side. A full outer join returns all records when there is a match in either the left or the right table. This means it combines the effects of applying both left and right outer joins. 16. How do you skip header rows when loading data into Hive table? Hive does not directly support skipping header rows when loading data into a table. However, there are several workarounds for this. One method is to load the data as it is into a temporary table. Then, while inserting data into the actual table, you can use a query to exclude the first row. Another approach is to use the --grep v command to remove the header before loading the data into the table. Additionally, if you are using Hive 0.14 or above, you can use the --tbl properties, skip, header, line, count, equals 1, property when creating your table to skip the header row. It's essential to review the Hive version and choose the method accordingly. 17. What is Object Inspector in Hive? An Object Inspector in Hive is a system component that provides a unified interface for both complex and primitive data types. It is primarily used to analyze the internal structure of data fields and their respective field names. This tool is instrumental in accessing and manipulating the data stored in Hive. It handles both standard and user-defined data types, allowing for greater flexibility in data analysis. Object inspectors play a crucial role in the execution of Hive operations. They are utilized in serialization and deserialization processes, as well as in data comparisons during query execution. Having an understanding of object inspectors can be beneficial for optimizing the performance of Hive queries and operations. In addition to the analysis of data types, object inspectors are also responsible for structuring and maintaining the hierarchy of table and partition metadata. This functionality enables Hive to manage and process complex data types effectively. 18. How can you optimize query performance in Hive? There are several strategies to optimize query performance in Hive. Firstly, consider using partitioning. Partitioning the data allows Hive to read less data when executing queries. Secondly, use bucketing. This allows you to distribute your data evenly across multiple files, resulting in faster data retrieval. Another approach is to use indexing. An index can be created on a specific column of a table, which can significantly speed up queries that filter on that column. Additionally, consider using vectorization. This feature significantly improves the performance of operations like scans, aggregates, filters, and joins, by performing them in batches of 1,000s of rows at once instead of one row at a time. Optimal usage of file formats can also help. Columnar file formats such as Parquet and Orc allow Hive to skip reading entire columns, thus improving performance. Lastly, optimizing the join type based on the data size and distribution can also significantly improve the performance of Hive queries. Remember, performance tuning in Hive often involves a combination of these strategies and depends on the specific use case. 19. What is hcatalog and how does it relate to Hive? Hcatalog is a component of Hive that provides a table and storage management layer for Hadoop. It allows users to store their data in any format they choose, whether it be structured or unstructured, and then provides a single view of this data. Essentially, hcatalog is a centralized repository of Hive metadata. It also provides a command line tool for users who don't use Hive to operate on the metadata. Hcatalog's main functionality is to abstract the storage details so that users can work with data without knowing where or in what format it is stored. It supports reading and writing files in any format for which a serde, serializer/deserializer, can be written. In relation to Hive, hcatalog shares the same metadata and thus, any data that is stored in hcatalog can be accessed by Hive. Using hcatalog, other tools like Pig and MapReduce can also read and write data in Hive tables directly. Hcatalog is a crucial part of Hive and Hadoop ecosystem. It allows different data processing tools like MapReduce and Pig to read and write data on grid more efficiently. By using hcatalog, one can access data in Hive Metastore without knowing the storage and file format. It effectively provides the necessary interface for reading and writing data in the grid and promotes data interoperability between Hadoop and other data processing tools. Hence, it simplifies data management in Hadoop and extends the power of Hive to other tools. 20. Can you explain how to create a table in Hive with specific properties? First, start by using the create table statement, followed by the name you want to give to the table. After that, specify the column names and their data types within parentheses. If you want to define specific properties for the table, use the tbl-properties clause. For example, to create a table named employees, with columns, name, string type, id, integer type, and department, string type, and with a comment property, you would write SQL. Create table employees, opening parenthesis, name string, id int, department string, Closing parenthesis. Comment, employee details, TBLPROPERTIES, creator, equals, self, created underscore at, equals, the 1st of January 2022, in this example, creator, and, created underscore at, are specific properties assigned to the table. Remember that the table properties are optional and can be skipped if not required. Always make sure that the data types you're assigning to the column are compatible with the data that will be stored in those columns. 21. Describe a scenario where you would prefer using Hive over Pig or Spark. Hive is often preferred over Pig or Spark in scenarios where the data processing requires SQL-like queries on large datasets that are stored in the Hadoop Distributed File System, HDFS. For instance, if you are working on an application that involves the analysis of historical data, Hive would be a suitable choice because it provides a platform for querying and managing large datasets residing in distributed storage using SQL-like syntax. Given its SQL-like nature, Hive is easier to learn and use for professionals who come from a SQL background. It is also more suitable for applications that require batch processing of large amounts of immutable data, such as log files or raw data used in predictive modeling. On the other hand, Pig and Spark are better suited to scenarios that require complex data transformations and for processing of real-time data. 22. How would you handle large datasets that exceed memory limits in Hive queries? To handle large datasets that exceed memory limits in Hive queries, you would need to utilize specific techniques. One of them is to use the set Hive auto convert join equals false command, which disables the conversion of common join into a map join. This method is useful as map join operations tend to consume a lot of memory. Another approach is to use the set mapreduce.job reduce slow start completed maps equals 0.8 command. This will delay the start of the reduce task, allowing more time for the map tasks to finish and thus decreasing the chance of running out of memory. Lastly, you can partition your data. Partitioning in Hive allows you to divide large datasets into smaller, more manageable parts. By doing so, you not only prevent memory overflows but also significantly improve the efficiency of Hive queries. These strategies can be particularly helpful when dealing with large datasets. 23. What challenges might arise when using Hive for real-time analytics? Hive, being a data warehousing solution, is not built for real-time processing. It's designed primarily for batch processing jobs. One challenge could be latency. Hive is not designed to give quick responses to queries since it uses MapReduce, which is not suited for real-time processes. This could lead to significant time delays. Another challenge could be resource management. Hive can consume a lot of resources if not properly managed. This might affect other applications running on the same cluster. Also, Hive does not support row-level updates, deletes, and inserts. This means that it might not reflect the most recent data, which is critical for real-time analytics. 24. How do you manage user access and permissions in Hive? Hive supports a variety of methods to manage user access and permissions. One common method is through Hive authorization, which comes in two models: default authorization, Hive's built-in system, and SQL-based authorization. The former uses user group permissions at the HDFS file level, whereas the latter uses SQL standard authorization, providing a more granular level of control over user actions. Another method is through Apache Ranger, a tool that provides comprehensive security across all Hadoop components, including Hive. Ranger allows administrators to manage access control policies, monitor and audit user access, and maintain a secure data environment. Lastly, Hive also integrates with Hadoop's Kerberos for strong authentication via secret key cryptography. Kerberos can prevent unauthorized data access by confirming the identity of users attempting to access Hive databases. It's crucial to choose the appropriate method suited to your data security needs and the skill set of your team. Hive's flexible options ensure you can maintain a robust and secure data environment. 25. Discuss a time when you optimized a slow-running query in Hive. What steps did you take? In one of my previous projects, I encountered a slow-running query that was causing significant delays. The first step I undertook was identifying the cause of the problem. By using Hive's explain command, I was able to gain insight into the execution plan of the query. This allowed me to identify that the query was performing a full table scan rather than using the available indexes. Secondly, I partitioned the data, which helped reduce the amount of data scanned during query execution. I also implemented bucketing on the table to distribute the data more evenly across the nodes. Third, I used a combination of inner and left joins instead of full outer joins, as they are more expensive in terms of processing. Finally, I made use of the sort by clause, which helped in sorting the data at the reducer side, thereby enhancing the query performance. Through these measures, I was able to significantly improve the query speed and overall system performance. We trust that this comprehensive guide on the top 25 Hive interview questions and answers has been illuminating and beneficial to your preparation. We've gathered these questions from real interviews to help you gain the confidence and knowledge necessary to excel. Remember, practice is the key to success. If you found this video helpful, please hit the like button and subscribe to our channel for more insightful content. Wishing you all the best in your upcoming interviews.